Welcome to Career Guidance Max playlist. So in this video I'm going to start unit 2 differential calculus. Okay. So in this differential calculus first we should know what is the function, how to represent the function. Okay. The very first basic definition is a function is a rule that assigns to each element x in a set A. So I'm taking one set, that is A. So which is your domain. Okay, from the domain I'll take the elements x generally. Here I taken x1, x2, x3, infinite number of terms we can take. Okay, in a set A. So to exactly one element called f of x in a set B. Okay, here I am taking elements, each elements in set A, it gives exactly one image from set B, that is called f of x. Here I am taking x1 element, it gives image in set B, f of x1. Here I am taking x2, it gives image in B, f of x2. I am taking x3 element, it gives image in B, f of x3, like that. So the set A is domain, the set B is codomain with the respective of the function. So this is generally we can call the function, the transformation A to B. Okay, the very simple. In A I am taking element, this each element in A gives one image in B, corresponding one image in B in the form of f of x. I am taking element from A now, it gives image in B in the form of f of A. Generally we can call. Okay, so this is called a function. We'll see how to take like that. So function means you can understand more when we give simple example. If we give one input, if we give one input in a function, it gives one output, right? If you give one input, it gives one output. That is called a function. For example, here I'll take f of x equal to generally 2x plus 1. Okay, input is called x, output is called f of x. This is your function 2x plus 1. Here I'm giving x equal to 1. When x equal to 1, you will get f of 1 is equal to 2 into x equal to 1 plus 1, you will get 3. And I am giving another input x equal to 2. I will get x equal to 2 into 2 plus 1, I will get 5. So this is called function. Okay, when you are giving one input, there must be one output. So here not possible one input equal to two output, not at all possible here. Okay, if you are giving one input, now definitely there must be a one output. So it's called a function. So here in the definition they represent domain and codomain. So this is A, this is B. The first we are taking element, that is represent domain. It gives image in set B, that is called that is represent codomain. In each element in A, that means I'll take x1, x2, x3. It gives image in B in the form of f of x1, f of x2, x3, like that. For example, I'll take the function natural number n to n. Okay, so the function is, this is domain and this is codomain. Okay, and the function is f. I'll take here function f of x equal to 2x. I'll take here 1, 2, 3, 4 example. Here x equal to, I'm substituting 1, I'll get 2. Here x equal to, I'll substitute 2, I'll get 4. Here x equal to, I'll substitute 3, I'll get 6. Here x equal to, I'll substitute 4, I'll get 8. So when I'm giving the input 1, I'll get the output 2. Okay. When I'm giving 2, I'll get the output 4. When I'm giving 3, I'll get the output 6. When I'm giving 4, I'll get the output 8. Okay. So one input gives one output, right? So this is called a unique function. Why? Because one input cannot give two output. That is not possible. One input cannot give two output. That is not possible. Okay. Simply you can understand less than form not possible in your function, in a unique function. One input cannot give two output, but two input can give one output, same value, like that. So less than is not possible, greater than is possible. Greater than means I will take two input, it give one output, that's possible. But one input not possible to give two output. We are dealing only real numbers. Okay. Generally in this differential calculus you are going to learn about only real numbers, how to apply. Okay, not imaginary. In engineering they are taken only real numbers, keep it in your mind. Okay, while doing problem it's important. And one more term we can see in graphical manner. So for example I will take this. This is one graph. Okay, I'll draw one straight line. The meeting points this one. So this is y1, this is x1. For example, the vertical line meets the graph at exactly one point, not more than point. It's called a function. It's called function. Okay, a vertical line exactly meets one point, it's called function. The graph. Second function, I'll take this one. The vertical line meets the graph at exactly 2 points. Okay, so this is x1, this is y1, y2, right? When I given the input x1, it gives two output. This is not possible, so it's not a function. Okay, a vertical line meets the graph exactly at a one point. It's a function because we given one input, we'll get one output y1. Okay, that is called a function in a graphical way. So now we are going to learn about what is domain in this video. Before going to start the domain, you should understand two concepts, that is closed bracket and open bracket. For example, here I am taking 3 to 6, here I am taking 2 to 1. If I am writing in a closed bracket 3 to 6, now this 3 and 6 are included. If we are writing in open bracket 2 to 1, now this 2 and this 1 are not included. Open bracket means the 2 points are not included. Closed bracket means these 2 points are included. So domain is nothing but what are all the elements we taken from a set A, that is called domain. For example, you will have one function f of x equal to 2x plus 1. What are all the points we can take? What are all the points we are going to apply here? That's called domain. From the domain only we are taking the elements. Okay, so after taking the elements, we are going to substitute in our function, we'll get the answer. That is our image, the set of all images taken from the set of all elements. Set of all the images collected from the codomain is called range. Okay, so that's the definition. Here I given that domain, the function f a to b, then set A is called the domain of the function. Already you know what is meant by domain. And codomain, the set B is called codomain. We take an element from A, that is domain, it gives image in B, that is called codomain. One element I taken from set A means this element gives the image in set B, that's called f of A. It's your codomain. Okay, the range. Already just now only I said what is meant by range. The set of all images of all the elements of A. So for in our A set, you will have the elements x1, x2, x3 and the infinite number of elements. It gives image, set of all the image under the function of f in set B. It's called of f of A model. So if you are taking the elements from A, it gives the image in B. That's called range. Range means is nothing but what are all the images are there in B, we have to write in collective manner. That is called range. Okay. So in this video we are going to see how to find the domain. For example, here we can take few more functions. Find the domain of the function. So first one is f of x is equal to 2x minus 1. So the function is a simple function. There is no denominator term or there is no square term. Simply we can take any number, but it should be real number. Minus infinity to plus infinity we can take. So the domain we can write simply minus infinity to plus infinity. Closed interval, open interval, open bracket, closed bracket. Here I am using open bracket because this minus infinity to plus infinity, we don't know what it is. It's not included. Anyhow, we'll get the point from this. Within that only we are taking the elements. So this is open interval means this minus infinity plus infinity not included. Okay. This is for domain for this function. Example, you can take second function. Here I taken the second function in terms of g of x. G of x or f of x. Function we can define, that's it. F of x equal to x square. Here also you will have only one term. The domain we can write simply, already we know how to fix the domain. Here also we can apply minus infinity to plus infinity real number. This minus infinity and plus infinity are not included. Okay. And third one is, we'll take f of x equal to square root of 3 minus x minus square root of 2 plus x. Okay. F of x equal to square root of 3 minus x minus square root of 2 plus x. Suppose here you will have only the function in term of 2x plus 1 or x square or minus x or whatever. You will have only one term. Now simply we can take the domain minus infinity to plus infinity. Here we couldn't take like that because you will have square root. Okay. In the square root, for example, here take the number 3 minus x, here 2 plus x, here I will take x equal to minus 1, 0, 1, 2, 3. Minus elements, all the elements. It gives a positive root. Here I am substituting x equal to 4. When I am substituting x equal to 4, I will get minus 1. When I am substituting x equal to 5, I will get minus 2. When I am substituting x equal to 6, I will get minus 3. So you will get the square root of minus 1, minus 2, minus 3 means square root of minus 1 or minus 2 means you will get I into square root of 2. That minus in square root is represent I. In differential calculus, you are going to learn only the real number. So here, this imaginary is not possible. That imaginary is not possible. So according to that, we have to take your domains. So this is your minus infinity and this is your plus infinity. The center point is 0. Consider. So left hand side you will have minus 1, minus 2, minus 3 and minus 4. Infinite number of terms. Right hand side you will have 1, plus 1, plus 2, plus 3, plus 4. Infinite number of terms there in your real numbers. So for example, suppose here I am substituting x equal to minus 4 means you will get minus 1. That means I. That means here x equal to 4 is not possible. Your x equal to 4 is not possible. Not exactly x equal to 4. You can apply exactly 3.1. The 3.1 itself not possible. So generally we can call here x equal to 4 is not possible. That means 4 to infinity elements are not possible for your domain. When you are substituting here x equal to real numbers of greater than or 4, you won't get the answer for this. When I am substituting the greater value of 3 here, you will get an imaginary part. So this 4 to infinity number of plus terms are not possible. You can see here the square root of 2 plus x. Here I am substituting x equal to 0, 1, 2, 3, 4, 5, 6, all the positive numbers, you will get the answer. But while substituting here negative number 0, minus 1, minus 2 is possible. When you are substituting here minus 2, what you will get? 2 plus minus 2, you will get 0. 0 also one output. When I am substituting minus 2, I will get the output 0. That's possible. But if I am taking here x equal to minus 3, is not possible. When I am taking x equal to minus 3, what will happen? 2 minus 3, you will get minus 1. That means minus 1 means square root of minus 1 is called I. I into root 1 is understood, that is I. Okay, imaginary part is not possible. So here minus 2, okay, that minus 3 is not possible. So minus 2, after that you will have minus 2.1, 2. That also not possible. Generally we can say minus 3 to minus infinity, not at all possible here. Okay, so we are writing the domain. How to write the domain here? Minus 2 possible, both the points. The minus 2 is possible. And 3 is possible. Okay, minus 2 is possible and 3 is possible. So how to write a bracket? So here we can write closed square bracket, both the term. We can apply here only in the term of minus 2 to plus 3. Otherwise you are going to get the answer here. So this is your domain for this special function. Whenever you will have square root, you have to identify the domain very carefully. So because here minus 2, after that all the elements we cannot able to apply, so we eliminated that. Remaining we return in the closed bracket. Closed bracket means this minus 2 included. Okay, here we taken positive number up to 3. Why? After 3, if you are substituting here 4, now you will get negative number. So that's not possible. So here we taken a closed bracket. That means this 3 also included, not more than that. So this 3 is included. For this function, your domain is closed bracket of minus 2 comma 3. Okay. And the fourth one, I'll write f of x equal to root of x plus 2. Okay. So already you know that root of x plus 2 means I'll write here minus infinity to plus infinity. The center point is 0. I'll write here minus 1, minus 2, minus 3, and remaining all the points. Here 1, 2, 3, infinite number of terms. If you are substituting a real number, positive number, there is no issues. 0, 1, 2, 3, 4, 5, like that, you will get the answer. But this side, in left hand side, if you are substituting negative term, minus 1 is possible. Minus 1 plus 2, you will get plus 1. Minus 2 plus 2, you will get 0. That's also one output. When I am substituting here minus 3, you will get minus 3 plus 2, you will get minus 1 imaginary part. When I am substituting more than 2 in terms of minus 3, minus 4, minus 5, minus 6, minus 7, like that, definitely you will get a negative term. Negative, it's converted to imaginary. Imaginary, here we are not dealing imaginary terms, so we have to omit. So here minus 3 to minus infinity, not at all possible. So I am writing the domain minus 2 included. Minus 2 included, comma, here infinite number of terms, open bracket we have to write. This infinity not included, so that we return open interval. So this is the domain for this root of x plus 2 value. Okay, and fifth one. The fifth one is the function f of x equal to 1 divided by x square plus x. So whenever your function will be in denominator, So you have to do carefully while finding domain. So you will have the quadratic equation for x square plus x. Maximum you can try to convert as a linear factor. From that I'm taking x outside. So I'll get x plus 1. Okay, wow. So this is your f of x. How to identify the domain? Simply we can say here, when I am substituting here x equal to 0, what you will get? 1 divided by 0 means infinity, indefinite function. When I am substituting here x equal to minus 1, again you will get a indefined function, right? So that here, if I'll take x equal to 0 means you will get the function f of x equal to infinity. When I am giving one input, there must be one output, but here there is no output. It gives infinite, indeterminate form. So that means there is no function here. So it's not possible. From that domain, we have to eliminate this 0. We have to cut this 0 element from that. I'll take x equal to minus 1. When I'm substituting x equal to minus 1, I'll get the function infinity, because minus 1 means minus 1 plus 1 0, 1 divided by 0, the entire term will be infinity. When I'm giving one input, there is no output, it's infinity. This is also possible, this is also not possible. So from your domain we have to eliminate this 0 and minus 1. How to write domain here? For example, you can write a real number. This is plus infinity and this is minus infinity. The center point 0. Here we'll write minus 1, minus 2, minus 3, infinite number of terms. Here we can substitute 1, 2, 3 up to infinite number of terms. So for example, except minus 1, suppose I am substituting here minus 2. When I am substituting minus 2 for x, I will get minus 1 and minus 2, you will get a value. When I am substituting minus 3, I will get the answer. When I am substituting minus 4, I will get the answer in a real number. Okay, and there must be some answer. It's not infinity or indeterminate form. The only in the case 0 and minus 1, when I am substituting here, I will not get the output. So from that domain, I am not taking this 0 and minus 1. That means outright. For example, the domain I am writing here, we start with minus infinity. We can apply infinite number of terms. Minus infinity, open interval. I'll write here minus 1. Okay, and open interval. That means this minus 1 is not included. And minus 0.99 also included. That's what I'll write here, open interval. And union of, I'll write again minus 1 to 0 in open interval. That means this minus 1 and 0 are not included. Within the term we may apply, you will get the answer. Then again union of 0 to infinity. 0 to infinity. This 0 and infinity are not included, so that we return open interval. This is your domain for this function. Okay. So next one, f of x equal to x plus 4 divided by x square minus 9. So here you will have the function both numerator and denominator. So this is called a quotient function. So here also we have to apply the numbers carefully. Okay, because denominator also in a function form x. So I am writing f of x equal to x plus 4 divided by x square minus 9. So I am substituting the point. Real numbers always we have to take. The domain we have to define. Domain means nothing but what are all the points we can apply here. Like that you have to identify. So here x equal to I will put 0. I will get minus 9. That's our answer. Okay. Here I am substituting x equal to 1. I will get answer. 1 minus 1. 1 minus 9. I will get minus 8. In numerator also we can apply x equal to value. I'll get the answer. But when I'm substituting x equal to 2, 2 plus 4, 6. Here 2 means 4 minus 5, 6 divided by minus 5. I'll get the answer, real number. When I'm substituting here x equal to 3, means 3 square. 9 minus 9, denominator equal to 0, numerator 7. 7 by 0 means it's indeterminate form. That means if I'm taking x equal to 3, it not gives the output. indeterminate form, so it is infinity. When I'm giving input 1, there must be one output, but here there is no output. For example, in the similar way, here I'll take minus 3. Rest of all will give the answer. If I take minus 3 means what will happen? In numerator minus 3 now I'll get 1. In denominator minus 3 whole square means 9 plus 9. 9 minus 9, 0. So 1 divided by 0 is indeterminate form. Again, this minus 3 is not giving a output infinity. So in your domain, I'm going to eliminate this 3 and minus 3. Remaining I'll write. That is our domain. Remaining all the values are eligible to apply here. You'll get the answer. So in real num, you take minus infinity to plus infinity. Okay. Minus infinity to plus infinity. So this is 0. For example, here you will get minus 3 and 0, here you will get 3. Okay, wow. So we have to eliminate only minus 3 and plus 3, right? So that domain I'm going to write. I start with minus infinity. Here I'm ending with the minus 3. So I'll write open interval because this minus 3 and minus infinity are not included. Within that we may apply, but exactly minus 3 is not possible here. And the union of, now I'm writing minus 3 to 0 and 0 to 3. Both you can add directly, you can write minus 3 to 3. This also not included because minus 3, 3, if you are substituting, you won't get the function value. So these two also not included. Rest of that, here I'm writing 3 to infinity. 3 to infinity means this 3 is not included, this infinity also not included. We have to write open interval form. So this is your domain for this function. Okay. And next one, the seventh one is the function f of x equal to 2x square minus 5 divided by x square plus x minus 6. So this is also quotient function. Already I told, in denominator you may have function means we have to do carefully while finding domain. So this 2x square minus 5 divided by this x square plus x minus x, as it is possible you can convert as a linear factor. This is quadratic equation. For example, you can take minus 6. The term, so 3 minus 2, multiply this 2, you will get minus 6. Add this 2, you will get plus 1. The coefficient of x should be 1, right? So I'll write here x plus 3 and x minus 2. This is your function. Now we can check the real numbers. What is our domain? Okay. Before finding the domain, see here you will have x plus 3 and x minus 2. Suppose here I am substituting minus 3. What will happen? Exactly I am substituting minus 3 means I will get minus 3 plus 3, 0. Anything divided by 0 will be infinity. So x equal to, when I am substituting minus 3, I will not get the output. It is infinity. We have to eliminate from the domain this exact number minus 3. In second function, here x and minus 2. When I am substituting exactly 2 means 2 minus 2, 0. Anything divided by 0 is here not at all possible. So x equal to 2 also we have to eliminate. When I am substituting x equal to 2, I will get infinity. There is no output. So that the line, the midpoint 0, this is plus infinity, this is minus infinity. Here you will have minus 1, minus 2, minus 3 like that. Here in right hand side you will have positive term 1, 2, 3 like that, infinite number of terms. Okay, wow. So first, exactly when I am substituting minus 3, I will get 0, right? So that we could not apply here exactly minus 3. We have to eliminate this minus 3. And here we could not able to apply 2. Sorry. Okay, 2. When I am applying 2, I will get 0 again. There is no function. Rest of all the elements are gives the function. Right? So that I will write here domain minus infinity to minus 3. Right? That means this minus 3 is not included. Okay. and union of minus 3 to 1 2. Okay, minus 3 to 2. That means this 2 and minus 3 again not included, and the union of I'll write 2 to infinity. Okay, this 2 is not included. We can apply any other term 3, 4, 5, 6, 7 like that, infinite number of terms. This is also not included, so that we'll write in a open interval form. So this is our procedure to identify domain. So in this video you learned how to find the domain. Closed interval not included, open interval closed interval it's included that point, open interval means not included. Okay, so we see in 7 functions how to identify domain. You just refer this, definitely you will get 1-2 mark from this section. Okay, for example in this third one, f of x equal to square root of 3 minus x minus square root of 2 plus x is important 2 mark. You will have only one function, there is no denominator term now, it should be a real number, there is no square root now. The square root means you will get negative values. Negative value means we not defined in a function in negative way. Square root of negative is not defined. Your function should be positive, so it's not possible. We are taking only real number. Okay, suppose you are having in denominator term x means you have to do carefully. When 1 divided by 0 means indeterminate form, you won't get the value output, so you have to do carefully. One thing is when finding domain, you should know whether it is square root or not. And one more term, in denominator there is a function, you should know. Always you should carefully do the problems based on that while finding domain. Okay, so that's it, thank you. In this video, once again I will recall, in this video we seen only domain based on the function. A is a domain, B is a codomain. Here I taken one element from A. Exactly this element gives image in set B. That is in time function of x comma 1 like that. Function of x1 we written. That is called function. Based on that we seen several problems. Domain, codomain, range. In range means is nothing but the set of all images of all the elements of A is gives image in B. That's called range. The range means the collective of all images we have to write. That is our range. In next video we'll see how to find the range. Okay, thank you,